Our next speaker works as a senior data scientist for Teradata, which is a global business leader in the area of data and analytics consulting. And she says, data is neither female nor male. In a data-driven world, there is no room for gender stereotypes. I really like this, and she has a very powerful name, Almerima Jamakovic-Kapic. And her talk is about diversity as key in the new age of data science. So the stage is yours, Almerima.
Thank you so much. Thank you so much. Thank you so much. So let me start by saying how inspiring it is to be here at CEBIT. Great honor to be here. Thank you so much. I would like to thank the organizers. For sure, my colleague Edith, who made it possible for us from Teradata to be here. My name is Almerima, and I'm a senior data scientist at Teradata. Teradata is a global business lead in the area of data and analytics consulting. And as a data scientist, I'm here for sure to talk about this wonderful new emerging field of data science. However, my talk will have a bit of focus on the importance of evolving data science in a way that promotes trust in diversity. So on my agenda, I have few things. And one of them is the small experiment in data science. And in order to, understand for you what I'm going to talk about, I'm going to go very shortly through a terminology tour that in data science I can imagine for a newcomer can be difficult. For a newcomer, it can be difficult to understand or to qualify opportunities to understand where data science can add value. So the first thing what we have is, and how do I switch to the next slide? Can somebody help me? Next slide. Just green. Very good. And the first question that I have here is, what is data science? I'm sure all of you are aware of the fact that data these days is flowing from all aspects of our lives in unprecedented amounts. Never before has there been so much data being collected, analyzed, used daily. And indeed, we may say that data is the present. We may say data is the future, and it is the fuel of the future. However, it first needs to be refined, and that is what data science is all about. So it is a kind of an umbrella term which encompasses a wide range of scientific techniques, methods, algorithms, systems, processes, all with one single goal: to extract new insights from data, hopefully enabling this new era of data-driven decision-making. Within the data science, for sure, in the past decade, we have made tremendous advances, and that happened in particularly on the two fields which are called machine learning and deep learning. So in order to understand what are these terms I'm talking about, I'm showing you the slides, which is about artificial intelligence projects. Two projects which will actually, they have the same goal. They want to solve this problem of human intelligence. However, what underlies these two projects are two different approaches. And the first project already 20 years ago by IBM. And the second project, something very recent. So I said what differentiates them is underlying approach to success. And in the first project, at that time, 20 years ago, techniques of good old-fashioned artificial intelligence have been used, let's say, and a bit of machine learning. However, probably at that time, we would not say, or that machine learning would not be the same as today. And in the second project, we have something that is using deep learning techniques. So artificial intelligence begets machine learning and everything else, believe it or not, and not the other way around, because artificial intelligence is entered, or this idea of artificial intelligence has been introduced in the 1950s already and entered the mainstream of academia already at that time as a part of the computer science, and consequently from this idea everything else followed. So machine learning and deep learning are just the subfields of the artificial intelligence. However, having different tools or using different tools in order to come to their goal. And machine learning very quickly often uses the tools of classical statistical learning techniques, and deep learning, on the other side, doesn't do that. It relies on something that we call artificial neural network. Artificial neural network is an idea that we borrowed from our human brain. And having these things in the pocket now, understanding a bit of the terminology, what we have in data science, I'm now going to show you a small experiment which I did last year when preparing this presentation. And this small experiment relies on the concepts or techniques of deep learning. Remember, deep learning uses something that we called artificial neural network. And what you see here, these dots, is an abstraction of an artificial neural network. These kind of problems, what I show here, recently we are able to solve them within data science quite well due to these advances which we made within the deep learning field. So what I did here, I wanted to solve a task of image classification, and I used neural network. However, I did not start from the scratch because there was no need to do that. I relied on the state-of-the-art solution, which is used nowadays in computer vision. What I did, I just built a few layers on the top of that so that the data which I input into my model would be classified correctly. So the data which I took is pictures from my colleagues from Teradata. I labeled them to be female versus male. I trained my neural network, and I built something what I called gender classifier. And I need to validate how good is my classifier, and there is no surprise that my classifier works well because I'm using state-of-the-art solution. So these 4 pictures, which I use to validate my classifier, they are all classified correctly. You don't see that, but I can, it is like that because I see on the numbers there. So these kind of problems are very well done these days due to the deep learning techniques. So this is an introduction to a bit more complex experiment which I'm showing you now, and that is the question, can we classify someone's profession based only on its visual, on the picture? And what do you think? No. Good. So let me share with you what I try to do. I follow the same procedure, used the neural network. I took the same data set, relabeled it differently. Now I relabeled it as data scientists versus the data engineers because I want to answer the question, is this person a data scientist or not? And after I checked how good my model is, I saw that my model wasn't really performing well. That is at no surprise, because in order to classify something, we need to give these 2 groups need to have these intrinsic features which are different from each other so that your model understands that or learns from that. However, that is not what I want to show you with this experiment. What I want to show you with this experiment is the first thing. is if the machine is not able to classify someone's profession on just the visual, the question is, why do we people do that quite often? That is first thing. The second thing is, what is more interesting here is that these 4 validation pictures, you will see these numbers above them. They tell me that my model is most uncertain about these cases or these groups for which I have the least available data. So after I did my experiment, I went back to check my data, which I fed into my model, and then I realized, okay, this data engineer, for which my model is least uncertain about, for this group of people, I have the least data going into my model. Then this female data scientist, the same holds for her. Then this group of data engineers, I have less available samples of data engineers than from the data scientist. So what I want to tell you with this is that model is more uncertain about those groups which have less representative data. Oops, and imagine now we are able to draw some kind of, we are to the corporate world we have today. Imagine we can do that. What is that we have in the corporate world today? Usually these questions like, is this a data scientist or not? Usually these questions are stereotypically answered like, yes, no, female is no, male is yes. And knowing this experiment or seeing this experiment which I showed you, now we can better understand why this happens. So there is no surprise why these questions are answered like that by our corporate world, because our world, or the modeling of data, is merely a reflection of that what we put into that. So data or the model input actually predicts and reflects that what you are going to see as the output. And as a data scientist, you know, you wonder what can you do about it. So you have 2 approaches as a data scientist to this problem. The first approach and the better approach is to fix the input data. So if you want that your model performs better and answers these questions in a better way, you need to throw more data at your model. So in our case, it means that we need to throw more representative data, because our model will then learn from the data and it will fix itself. The other approaches are about fixing the model. So you have the data as you have, but then you have to embed something in your model which is about, for example, some parameter or something in your model which will actually take care of this bias, what you have towards a certain group. And I'm not going to, you know, this kind of solution you see today that your companies are trying to come up with policies with some kind of different things, for example, to fix the gender diversity or gender, but you know, I'm not going to, so these things would rather fall into the group fixing the model. I'm more interested into this problem, how can we actually make sure that we have a representative number of female, males going into our corporate world model so that the model would learn from itself. And after checking a few of the literatures, I saw there is something which is called perceptual barrier. So perceptual barrier is something like women perceive studying one of the STEM fields as being unpleasant, or following a career path in technology and science being uninterested. And in order to somehow fix this problem within data science, we have a solution, I hope. So within data science, what I show you here are the skills which make a data scientist being a great data scientist, differentiator skills. And if you look carefully to these skills, then you will see that these things are not about knowing how to code better or doing the math better. No, these things are all about these skills in which women traditionally excel. And for example, data science touches every function in the business. And as a data scientist, you need not only to gather the data, analyze the data, you need to translate this insight into the language of the people to whom this message is intended to. Departments, different departments in the organization, sales, marketing, IT, they all talk different languages, and as a data scientist, you will need to be able to translate that, what you learned or taken from the data, into that something that is valuable for them and valuable for the organization that you work for. So this holistic view of a situation is a very important asset that a data scientist could have. And yeah, I would say that in order to take the full value out of the data science, one of my senior colleagues would say we need to be less mechanical in mathematics and more, and to do those more soft skills. Good. So, however, there is always however, all these skills which I mentioned, they are difficult to find in one person, right? They are very difficult to find. And that is a very straightforward and very simple reason why we need diverse teams. So it has been shown in many different ways that diversity is simply a competitive asset for a company. And at this point in time, I don't think there is, I don't need to be to advocate more for the diversity, for we all understand that companies who embrace this concept of diversity really make, yeah, like economic benefits of that. And my final two slides are about data science. Data science brings new ideas, new concepts, new ways of working. And I truly believe that female data scientists are natural candidates to drive this competitive advantage for organizations. And a key to a success, maybe a small observation from my side, I notice quite often that women and confidence, two terms, they are usually not going hand in hand. So as a data scientist, I would say there is these two things, if at all correlated, they are negatively correlated. And negative correlation means that if the value of one term goes up, the value of the other term goes down. And I wish that for us women, these two terms would be a more positive correlated, and I truly believe that data science is a way to open up for women and find their place in the world. So I thank you, and herewith I close my presentation, and hopefully we have a chance to talk.